Hello students, welcome to my channel Engineers Academy. Now today in this lesson we are going to learn the method of sections while solving the truss problems, right? So far we were solving such kind of problems by using the method of giants method, right? So this is the sample problem from engineering statics by Meriam, right? And we are going to learn the method of sections, right? So in this sample problem, it is said that calculate the force in member dj of the Hove roof truss illustrated, and it is said that neglect any horizontal component force at the supports, right? So before going to solve this problem, we need to find some angles, right? And we need to find some lengths, right? So let's say that this angle is, let's say, theta, and let's say this angle is alpha, right? And let's say we want to find this CK length, right? This CK member length, right? We are given this DJ member length as 6 meter, right? And it is said that here from A to G we have 6 panels at 4 meters, right? So this AL length is 4 meters, so LK, all these members have 4 meter lengths, right? So now first we need to find this theta. So we can find this theta by using this triangle ADJ triangle, right? So if we apply tan theta to ADJ triangle, so from ADJ triangle we can say that tan theta is DJ divided by AJ, right? Or we can say that DJ is 6 meter, this is given, right? So we will write that this is 6 and AJ is 4 plus 4 plus 4, right? So this is 12. So this is 6 divided by 12, right? And if we find theta by taking tan inverse, so tan inverse and 6 divided by 12 is 1 divided by 2, which is 0.5. So theta is 26.57 degrees, right? So this is that theta which we will require in our calculation, right? So this theta is 26.57. Now if you want to find this alpha, so to find this alpha, first we need to have this CK length. If you want to apply tan alpha to this small triangle, this CJK triangle, right? So if I write that tan alpha is equal to, so we can write that this will be equal to CK length divided by KJ length or JK length, right? So we know this KJ or JK length, this is 4, right? So we can write that this is 4, but we do not know this CK length, right? So we can find this CK length from by using the properties of similar triangles, right? So as we can see that this ADJ and ACK both of these triangles are similar triangles, right? So by using the properties of similar triangles we can write that CK divided by AK, right? These are the sides of this triangle, ACK triangle. So we can write CK divided by AK. This will be equal to DJ. We will take the ratio of the corresponding sides of the other similar triangle, right? So this will be, if this is CK, so CK is the perpendicular of this triangle ACK, and DJ is the perpendicular of ADJ triangle, right? So we will write DJ, and then we will, this AK is the base of this triangle, so the base of this ADJ triangle is AJ, right? So we will write AJ. So now we can write CK, and AK length is from A to K is 4 plus 4, so this is 8. So this is equal to DJ. So DJ is 6 and AJ is 4 plus 4 plus 4, so this is 12. So from this CK is equal to 4 meters, right? So now we know this CK length, we can write that this is 4 meters. So now if we apply this tan alpha, right? So tan alpha is equal to CK, which is 4, and this length is 4. So this means that alpha is equal to tan inverse 1. So this means that alpha is 45 degrees, right? We can directly say that if this is 4 length and if this is 4 length, so then alpha is directly 45 degree angle, right? So now we can write that this theta is 26.57, right? Let me write this as theta, and this alpha is 45 degrees, right? So let me write it here. So theta is 26.57 degrees and alpha is 45 degrees, and CK member length is 4 meters. Now the next thing we need to do is to find the reactions at point A and G, right? So to find the reactions at A and G, we will follow the same procedure, right? We will consider the whole truss and we will find the reactions at A and G point, right, at the supports, right? And in this problem it is said that neglect any horizontal component, right? So there are no components. We will neglect the horizontal components of the reactions at point A and G, right? So now we will consider the whole truss. So now if we apply the summation of moment at point G equals to 0, right? So if I write that the summation of moment about point G equals to 0, and if we consider that the counterclockwise moment is positive, so as we can see that this 10 kilonewton force is producing the clockwise moment about this point G, right? So we will write this is 10 kilonewton and the perpendicular distance of this 10 kilonewton force from that point G is 4 plus 4, right? So this is 8. So we will multiply it with 8. Similarly, this 10 kilonewton force is again producing the counterclockwise moment about that point G. So we will write again plus 10, and the perpendicular distance of this 10 kilonewton force from that point G is 4, 4 plus 4 and plus 4. So 4 times 4, right? So this is 16. And then again this 10 kilonewton force is producing the counterclockwise moment about that point G. So we will write plus 10, and the perpendicular distance of this 10 kilonewton force from that point G is 20 meters, right? So this is another 4, right? So we will write that this is 20 meters. And now as we can see that this reaction at A is producing the clockwise moment about that point G. So we will write minus, and the perpendicular distance of this reaction force at A is 6 panels, right? So we have 6 panels and each of 4 meters. So the total distance of this A from that point G is 24 meters, right? So we will write A multiply by 24, or we will write 24A, and this is equal to 0. So from this equation the reaction at A is equal to 18.33 kilonewtons, right? So now we can write that here we have a reaction force of 18.33 kilonewtons, and now if we want to find the reaction at point G, right, so then we can apply the summation of forces along y equals to 0, and the upward forces will be taken as positive, right? So now this A is acting in the positive direction, right, in the upward direction. So we will write plus 18.33, then this one is minus, so we will write minus 10, then this minus 10, right, and then we can see this is also minus 10, and G is acting in the upward direction, so we will take it positive, right? So this will be equal to 0. So from this equation the reaction at point G is 11.67 kilonewtons. So now we can write that the reaction at point G is 11.67 kilonewtons, right? Now in this particular problem we are required to find the force in this DJ member, right? So in method of sections what we do is that we pass a cutting section from that particular member where we are interested to find the force in that member, right? So in this particular problem, if we want to pass a cutting section from this DJ member, right, so we can either pass a cutting section like this, or we can pass a cutting section like this, right? So as we can see that both of these cutting sections are passing through 4 members, right? Now if we pass this as a cutting section, right, so then we will have 2 sections. One section will be the left hand section and the other one will be the right hand section, right? Let's say that we pass a cutting section like this, right, and we consider this left hand side of this truss, right? So now as we can see that this will be the DE member force. Let's say that we assume that all the member forces are acting away, all the member forces are the tension forces, right? So let's say this is DE member force, this will be DJ member force, right, and this one will be CJ, and this one will be KJ, right? And let me isolate this section which we are considering. We are considering the left hand section, right? If we apply the summation of moment about this point J, so as we can see that the line of action of this Cj force is passing through this Kj force is passing through this point J, and similarly this Dj member force is passing through that point J. So they will not produce the moment about point J, right? So if we apply the summation of moment about point J equals to 0, so then we will be able to find this dE member force, right? Since this is producing the moment about that J, and this 10 kilonewton, this 10 kilonewton force, and this reaction at point A is producing the moment about point J. But now, since in this problem we are interested to find the force in member dJ, if we consider this particular section, then we will not be able to find this dJ member, right, by using the other two equations, that is the summation of forces along x and the summation of forces along y equals to 0, right, since we have three unknowns here, right. So now to solve this problem, first we need to pass a section in which we have lesser number of unknowns. When we pass this particular section, we have 4 number of unknowns. This dE is unknown, this dJ member force is unknown, this Cj member force is unknown, and this Kj member force is unknown, right. So in this particular case, we need to pass a cutting section where we have less number of unknowns, right. If we consider this section, this one section, right, this cutting section, right, this dash line, so then we will have 3 unknown forces, this Cd member force, this Cj, and this Kj member force, right. So then if we consider this cutting section, and then after that if we consider this left hand side of this truss, so then we will be able to find this Cj member force, and that will help us in finding the dJ member force, right. So before going to consider this section, let's say this is section number 2. If before going to consider this section number 2, we will consider this section number 1, and then we will find this Cj member force, and after finding that Cj member force, we will consider this cutting section to find that dJ member force, right. So let me pass a cutting section, this section 1, then we will have this Cd force acting like this, right. We are considering all the forces are acting away, that we are considering that all the member forces from which the cutting section is passed is the tension forces, right. So let's say this is Cj member force, and this is, let's say, Kj member force, right. And now we are considering this portion, right, this left hand side. So let me write that this is Cd, this is Cj, and this is Kj, right. Now if we apply the summation of moment about the A point, right, if I apply the summation of moment about point A equals to 0, so now as we can see that this Kj member force is passing through that point A, so it will not produce the moment about point A, and as we can see that this Cj force is producing the moment about point A, and this Cd force is passing through that point A, so it will not produce the moment about point A. So as we can see that if we apply the summation of moment about point A, so there will be only one unknown, and that is Cj member force, right. So so this equation will give us the Cj member force, right. And once we have this Cj member force, we will consider that section 2, and then that will enable us to find the force in this dJ member, right. So now if we apply the summation of moment about point A, so and if we consider that the counterclockwise moment is positive, so this 10 kilonewton force is producing the clockwise moment about point A, so we will write this is 10, and this is clockwise, so we will write minus, and the perpendicular distance of this 10 kilonewton force from that point A is this 4 meters, so we will multiply this with 4. Similarly, this 10 kilonewton force is producing the clockwise moment about that point A, so again I will write minus, and this is 10, and the perpendicular distance of this 10 kilonewton force is 4 plus 4, so this is 8. And similarly, this Kj and this Cd are not producing the moment about that point A, so this Cj force is producing the moment, so we will consider components of this Cj force, right. So if we consider the components of this Cj member force at this particular point, this J point, right. So as we can see that this Cj member force will have one component in this direction, right, at this particular point, and it will have one component in this direction, right? And if we know this angle, right, so we know this angle is 45, we have determined it already, right? So if we know this angle, right, so this will be the sine component of Cj, this one is the sine component, and this one is the cos component, right? This is Cj cos of alpha, and this one is Cj sine of alpha. We can write that this is Cj sine of alpha. Now, as we can see that if we consider the component of this Cj member force at this particular point J, so then this cos component is passing through that point A, so it will not be able to produce the moment about that point A. So as we can see that only this sine component of this Cj member force is producing the moment about that point A. And as we can see that this Cj sine component is producing the clockwise moment about that point A. So we will write minus Cj sine of alpha, and the perpendicular distance of this sine component from that point A is 4 plus 4 plus 4, right? So this is 12. So this will be equal to 0. So now if we bring this Cj to the other side of equation, so this will be equal to like this, and then this alpha is 45, we know this is 45. So from this Cj is equal to minus 10 into 4 minus 10 into 8 divided by 12 sine of 45 degrees. So from this Cj is equal to minus 14.14 kilonewton, right? And as we can see that this Cj is acting away from this point C, but since we have negative sign here, so this means that the direction of Cj is in the opposite direction, so this means that Cj is acting towards the joint. So this means that Cj magnitude is 14.14 kilonewton, and this is compressive force, right, since it is acting towards the joint, right? So now we know Cj member force. Now to find the force in the dj member, right, so what we need to do is that we need to consider another section, another cutting section, right? So now I will pass that section number 2, right, and that section number 2 is cutting this dj member, right? So once we cut this dj member, so then we will be able to find the force in this dj member, right? So now we will pass this cutting section which will pass through this dj member like this, right? And now we know this Cj member force, and this is a compressive force, right? So we can write that this is known, this is compressive, and its magnitude is how much? 14.14. Let me write it here. So this is 14.14 kilonewton, right? And now if we consider the left hand side section, right, then we will have this de member force, this dj member force, and this kj member force. And again I am assuming that all these member forces are tension forces, right? They are acting away, right? So now if we apply the summation of moment about point G equals to 0, right, we are finding the moment about this point G, right, at this support. So now as we can see that if this is the de member force, so this is passing through that point G, so it is not producing the moment about that point G, right? Similarly, if we consider this dj member force, so it is producing the moment about that point G. This kj member force is passing through that point G, so it will not produce the moment about that point G. And this cd, this cj is now known, and it is producing the moment about that point G, right? So again we will consider the components of this Cj member at this particular point J. So now if this Cj force is acting in this direction, so it will have two components. It will have one component at this particular point J, this direction, right? So this is that Cj member force, right? And this angle is 45. So again this is the sine component, this is Cj sine of 45, and this one is cos component, right? So now if we apply the summation of moment about point G equals to 0, and if we consider that the clockwise moment is positive, right, and if we consider this section, right, so this 10 kilonewton force and this 10 kilonewton force, both of these are producing the counterclockwise moment about that point G. So we will write plus 10, this 10 kilonewton force has a distance of perpendicular distance of 16 meters from that point G. This is 4 plus 4 plus 4, so we have 4 panels, right? So it is 4 times 4, so this is 16, and this 10 kilonewton force has a perpendicular distance of 20 from that point G, and it is producing the counterclockwise moment, so we will write plus 10 and the perpendicular distance is 20. And similarly, this A reaction have a distance of 24 meters from that point G, and it is producing the clockwise moment about that point G, so we will write minus, and this is 18.33, and the perpendicular distance is 24. And again, as we have discussed, that this is the cos component of this Cj, so it is passing through that point G, so it will not produce the moment about that point G, so only this sine component is producing the moment about that point G, and it is producing the clockwise moment, right? So we will write minus, and this is Cj sine of 45, and Cj is known, this is 14.14 sine of 45, and the perpendicular distance is 12, right? So 1, 2 and 3, so 4 into 3 is 12, right? So we will multiply this with 12, and this dj member force is also producing the moment about this point G in counterclockwise direction, right? So we will write plus dj, and the perpendicular distance of this dj member force from that point G is again 12. This is 1, 2 and 3, so it is 4 times 3, so this is 12, and this is equal to 0. So now as we can see that in this equation we have only one unknown, right? So if the magnitude of Cj was not known, right, so if we haven't calculated the Cj member force, so then we will not be able to find this dj member force directly, right? Now from this equation, dj is 16.67 kilonewton, and since it is acting away from this joint D, so this means that this is the tension force, right? So this is how we apply the method of sections to solve the particular member force which is required to be determined, right? So this is the method of section that we will apply in the coming problems.